Alright, so let's create a physics model for our two-phase flow. Double click physics models, select implicit unsteady, select multi-Eulerian multi-phase, and use the volume of fluid model, which enable us to use more than just one species in our computational domain. We like to use turbulence model and apply K-epsilon turbulence model in our case. Of course, we need to use gravity in our simulation. So that's all model we need in our simulation here. Alright, then remember to set up the gravity. So by default, the gravity is point downward in z direction, which is negative 9.8 in z direction. That I think that's pretty much match our computational domain, so we are good for gravity here. Then let's go to Eulerian multiphase here, because we need to assign different fluid in our simulation. So let's just click new here. So this is phase 1. Let's click another fluid, so create another new fluid. So there's will be phase 1 and phase 2 fluid. Double click the phase 1 model. I would like to make phase 1 become gas and constant density. That should be good because we are not in high Mach number in our case. In phase 2, liquid is our option, and we select constant density. So in StarCCM software, by default, if you select gas constant density, then the density will follow the air property. If you would like to change the density and viscosity, you could expand more material properties inside, then you could change the density and viscosity inside. But by default, it is air. And also, if you select liquid, then by default, it is water. But you could change the density and viscosity to some different fluid you would like to define. Alright, so in our case, we simply just use air and water. So let me rename phase 1 into air, rename phase 2 into water. So that's my setup right now. So that's let's go to initial conditions of physics for volume fraction. So I would like to set up this fluid domain, and at the very beginning everything is air inside, so air fraction will be 1, water fraction will be 0. So that's the initial setup. And also for the air outlet, in the physics value, go to volume fraction as well, and that setup air is equal to 1. Also go to water inlet, physics value, the same section, volume fraction, and we would like to set water is equal to 1 in water inlet. Alright, and then I think that's all about the setup in region. Let's go to solvers. By default, the time step is 1 millisecond. So we will talk about Coulomb-Frege-Lewis condition later. If our simulation is doesn't look right. So let's stop our physics setup right here and go to simulation part.